Now I'm going to talk about types of vector. The first is equal vector. Two vectors are said to be equal if they have same magnitude, or I could say that magnitude, direction as well. And one thing that I'm going to discuss is between the mean. For example, this is a vector and this is 2 meter per second east, right? Then this is b vector and this is 2 meter per second west. We know that the magnitude of vectors are equal, but yet again the direction of vector, which is a, is not equals to b. So this is not an equal vector. We have one more example as a vector is equals to 2 meter per second in east, and yet again b vector is equals to 3 again 2 meter per second in east. So now we can say that a vector is equals to b vector, which means direction is same, and as well as magnitude of a vector is equals to the magnitude of b vector. But there's one more example. Let me you guys can tell me that is it vector or not, right? Equal vector or not. For example, a vector 2 meter per second in north, you can take any direction here. B vector, which is 2 Newton in north yet again. Okay, so I could say that now you can say that magnitude is same, direction is same as well. So is this an equal vector? My answer is no, just because their units are different. And for vector, we need to know that the unit should be same as well. In order to become a equal vector. Now I'm going to discuss about the last second type of vector, which is negative vector. Negative vector. Now what is negative vector? Okay, which has same magnitude but in opposite direction, right? For example, a is equals to 2 meter per second east and b is equals to 2 meter per second west. So we can say that these both vectors are, this is east and this is west. So these both are vectors are opposite to each other, which means they are negative vector. Only the magnitude of the vectors is same, else their directions, direction of vector a is equals to minus direction of vector b. This is a, this is right. So this we can say that the magnitude is same but the direction often different. And if we're going to do the parallel shifting, this is vector a, this is vector b. Now we're going to do the parallel shifting, joining the tail to tail of the joining tails of two vectors. So we can see that the angle that is formed between them is 180, right? The angle, because they are anti-parallel to each other, right? So the vector that is angle is formed between them is 180 degree. So this is a negative vector. Now I'm going to discuss about what is parallel vector. Two vectors when joined tail to tail, when actor to join tail to tail, an angle that is formed between them is 0 is known as parallel vector. As for instance, we can walk through example as well. This is a vector a, this is a vector b. Now I'm going to do the parallel shifting like this. So we know that now the directions are same, magnitude is same, and the angle that is formed between them theta is equals to 0, which means that this is vector A. Now I can do the parallel shifting of this vector as well. I can bring that vector here as well. Although the direction and magnitude remain same, only the parallel shifting of vector. So this is parallel shifting of vector, and theta here is 0. So this is parallel vector, and anti-parallel vector is just the opposite of it, which means that when two vectors are joined tail to tail like this, and the angle that is formed between them is 180, where the magnitude and unit may or may not be changed. Magnitude or unit may varies. Simple, it varies, right? So this is anti-parallel vector. And what is collinear vector? A vector which lie on the same line like this. These are the two, A vector and B vector. It lies on the same line, is known as collinear vector.